Good morning, geometry students. Happy April 1st, April Fool's Day. Coming at you here from my house. Again, another lesson ready for you, 9.2. Moving on in Chapter 9. We're doing translations today. But before we jump into the lesson, I want to quickly give you the answers for the homework assignment that I assigned from 9.1. Because most of these, I think all of these are graphs, I'm going to give you the answers that the book already has written. So if you need to pause these, feel free. But here is 5 through 9. So here we go. Number 5 is right there. Number 6 is right there. Once again, if you need to, pause, check your answer, see that it matches. Alright, let's jump to number 7, 8, and 9. Can I get it on here? Nope. Alright, moving the camera. Here is 7, 8, 9. And then we also have 10 through 14 even, so there's number 10. Pause it if you need to. Here is 12. There's 14. Nice little reflection of that hexagon there. And then we jump to 18, 20, and 22. So, alright, here we go. Checking answers. 18, 20, 22. So, got the answers. Check them. Make sure you're doing this. Make sure you're staying on top of your homework. I think the worst thing you can do during this break is just kind of watch the videos and push off the homework, or maybe do one problem and then just say to yourself, I'm fine, I don't need to do this. Once again, I think that's the worst thing you can do. Keep staying on top of your homework. Students, it's your responsibility to get caught up, to make sure that you're actually learning this information. Please do not get lazy on me. Make sure you're writing this stuff down. Make sure you're copying this stuff in your notes. Just like if we were in class, we'd be sitting down, we'd be teaching together. I'd be putting this stuff on the board, and I'd be asking all of you to write this stuff down. So stay with me, hang in there, and you'll be fine. So, all right, geometry lesson for the day, translations, 9.2. Let's go ahead and get started. Go ahead and have this written at the top of your notes, right next to translations, because a lot of kids really don't know what a translation is, so let me break it down into normal words for everybody. A translation, another name for a translation is a slide. So there's a famous song at weddings. What is it called? Is it the Cupid Shuffle? Or it's it's a slide to the left, slide to the right, crisscross. You guys, you ever been to a wedding and you're dancing on the dance floor? You know what I'm talking about, or even at a homecoming or prom. But there's a slide to the left, slide to the right, also known as a translation. So, in our notes, you don't have to write this down. That's just the homework from 9.1. Let's draw an example of a translation. Everybody, here's a slide. Let's go ahead and start your notes off with a stick figure. He's getting ready to slide. So, we are going to slide him. With every translation that you see in your homework tonight, that I'm going to get you at the end of these notes, you're always going to get an image and you're going to get a translation vector. Folks, here is your image. I'm going to use a basic stick figure. In my first couple examples, you're going to see I'm going to use triangles, I'm going to use quadrilaterals, but let's just use a stick figure. And then you will see a translation vector. So, let's do an arrow going this way. Folks, here is your translation vector. It's an arrow. It really represents two things. A translation vector represents two things. It represents a direction that we're going to slide. As you can see, we're getting ready to slide this stick figure that way. So he is going that way. He's not going up and to the right. He's not going straight up. He's not going down and to the left. We have a direction that he is clearly going, and it's this way. I'm trying to map my pen up parallel with this translation vector. And the other thing the translation vector shows is a distance. You know, we got to figure out how far we're actually sliding this guy or this gal. Here, let's make it a gal. Let's give this gal a 1970s perm. We got to slide this gal. How far? Well, we're kind of going this much space. We're not going to slide this gal all the way down here because that's just too far. I know it's this direction, but the distance is right there. There's a direction, there's a distance. So everybody, I'm going to turn my paper. I'm going to try to slide, translate this 1970s disco girl that direction. I'm trying to make this arrow exactly the same distance and same direction, so it's going in that direction. You can kind of see how I'm trying to make these lines parallel. Okay, looks good. Now we need to draw her right here. So I'd like you to draw the exact same image. Oh, perm's got to be the same. Folks, that's a translation. That's it. That's my lesson today. Now, of course, we're not going to draw any more stick figures or perms from the 1970s, but we are going to jump into some geometric figures. Triangles, quadrilaterals, you'll see. All right, example 1. I'd like you to copy the figure. And given translation vector, period. Copy the figure and the given translation vector. Then draw the translation of the figure along the translation vector. Alright, I'm going to get my ruler out. I got a ruler today, everybody. Check it out. Okay, let's make this, I'm going to go down a little ways. Give yourself a little bit of room because I'm going to have this image going up and to the right. You'll see in just a sec, so we need a little bit of room up and to the right. Put a point here, and I don't know, point right there. I'm making 4 vertices. Let's call this G, H, I, and J. Okay, I'm going to connect these. So we got ourselves, well, it's not a square. Is it a rectangle? No. It's just a quadrilateral. 4-sided shape. Is it a trapezoid? No. Kite? No. Rhombus? No. Alright. Copy the figure. Now you're going to have questions like this in your book, in your homework assignment tonight. They're just going to say copy the figure, so sometimes it's a triangle, sometimes it's a hexagon, you know. Just copy the figure, try to get it identical to what the book is. And then they're also going to give you a translation vector. Here's the vector, folks. I'm going to make it this long, kind of going up and to the right, just a slight tapered angle up and to the right. And we're going to call this vector W. Now, this is really not important. This is just how you're going to see it in the book. It's just vector W. It's how they denote it, how they identify this vector. So we are going to slide this quadrilateral up and to the right. So here's what we're going to do. And honestly, if you have a ruler, it's going to make things a whole lot easier. So let's do this. I need to turn this sideways because I need to measure the distance of this vector. Now, for me, the distance is going to be a little different from you because all of our vectors are going to be a little bit different. But I'm kind of looking at, I'm going to measure this in centimeters. 1, 2, 3, 4, 5, 6. It's just under 7. What is it? 6.7 centimeters. Kind of looks like 6.7. Let's write that here. 6.7 centimeters. So what you need to do is you need to slide every single one of these points 6.7 centimeters in this direction. So let's start with point I. So here we go. See if we can do this. 6.7 centimeters. I'm going sideways on everybody. Sorry. It's the only way that my ruler can kind of fit without blocking the camera. Alright, going in this direction. Let me go out. Here, let's change colors. Shall we? 6.7. Stop right there. Notice how it slid this way. That should be the exact same distance as your translation vector. It is. Does it look like it's going in the same direction? Kind of does. If you're doing this right, folks, this vector and your translation vector should be parallel because they're going in the same direction. They have the same slope, everybody. Alright, I'm going to put I right here. Actually, this is I prime because you just slid it. You just translated it. This is not a reflection today, everybody. We're doing slides. Alright, next one. H. Let's slide H. I think you can do this yourself. Here, 6.7. We're going kind of upside down on everybody. Okay. That should be about 6.7. Here. That should be H prime. Okay. Once again, we kind of slid this up and to the right. That should be parallel to the original. Okay, hold on to those. And let's do G now. Okay. Honestly, if this new line I'm about to draw is parallel to that line, then it's got to be parallel to this line. It's kind of the transitive property there. 6.7. Right there. G prime. Kind of over my directions, but that's okay. Sometimes it does that. And then we got to slide this one as well. 6.7. Parallel is key. Notice how the bottom of this ruler looks parallel with that vector. The closer you can get to parallel, the better this image is going to look. Make sure you go the distance of, for me it's 6.7. Maybe for you it's 4 centimeters. Maybe for you it's 3 inches. You know, everybody's is a little different because we got different notes, we got different drawings. There's J prime. Alright. So, hopefully if you're with me, we're taking this original image. Let's go ahead and color it in. This quadrilateral, G, H, I, J. So we are sliding this image up and to the right. So I slid every single point up and to the right. That distance, that direction, and we got these 4 new points. Go ahead and connect them, please.